Hello class. In this video we're going to be going over how to solve proportions. Before we do that we should know what a proportion is, and basically a proportion is just a way of writing two ratios that are equivalent to one another but look a little bit different. And the easiest example of this is saying that 1/2 is equal to 2/4, and I know these are proportional because they have a scale factor of 2 going from left to right. Now, in my first example, I'm going to show you more than one way to solve proportions. Now, the first way you can do this is by the way we've learned from previous examples. I can just go from one ratio to the other. I know my scale factor from 1 to 5 is 5. So 2 times 5 gives me 10. Now, I can also go from numerator to denominator and vice versa. I see that 2 is twice as much as 1, so 5 times 2 will give me a value of 10. So there's two ways to solve this. You may use any way you see fit, whatever you feel is easier for you to solve the problem. In our next example, we can also see we have two examples, and this is a key example of showing you that having more than one way to solve these problems is beneficial. Now, in our first example, I'm going to go from one ratio to the other, so from 3 to 4. So that means I'll have to go from 27 to x. Now, you'll see here that there's no nice whole number that will multiply from 3 to 4, so I will have to do a little bit of math to solve that. So I know that 3 times something gives me 4. I'll divide by 3 to figure out what that is. And I'll see that my scale factor from left to right is actually going to be this right here, because I can't reduce it, which is 4/3. So that means I'll also have to multiply 27 by 4/3, which will get kind of messy, and I'll just let you know right now, just to save us some time, that this will be 36. And I can do all of this work and have to multiply 27 by 4/3, or I can just go from my numerator to my denominator. I can see that this is multiplied by a factor of by 9. So 4 times 9 is 36. So again, you'll see why it's beneficial to have more than one way, just to save yourself some time, make things a little bit easier on yourself, or it's just a way of checking your own work. Again, we have an example. We can go from here. We're not going to be multiplying, actually. We'll actually be dividing. So from 18 to 2, I can see we're dividing by 9. 27 to 3 will be dividing by 9. And this will give me a value of 3. And I can go from 18 to 27. I know 18 times something gives me 27. I divide by 18. This cancels out. And I will get 3/2. Once I reduce this. If I multiply both of these by 3/2, I will see that I still get a value of 3 as my missing value. Now, the most common question I get from students is, how do you know which direction the arrows go? And the best way to explain that is just always follow, or I shouldn't say follow, but go towards the x. You'll see in every single one of my examples, no matter which direction we're going, our value always goes towards the x value, no matter what. So always follow the x. That'll tell you the right way to find your scale factor, or what direction to go. Now, our proportions won't always be written out for us. We'll actually have to write them out at times. So in this example, we see that we're comparing two things. We're comparing hours and the money that we earned. Now, before we write our proportion, we're going to have to write a word ratio, and this is just a nice way of keeping our data organized. So in my numerator, I have hours. In my denominator, I'll put money. And again, I'm going to write this two separate ways just to show you that you can solve them in either way. I know that we go from 8 hours and $72, and now we're solving this for 2 hours, but I want to know how much we get paid. So again, that ratio is 8/72, which is equal to 2/x. From 8 to 2, that's being divided by 4. From 72 to x, we're also dividing by 4. So this should give me, I believe, 18. Now I'm just going to double check this by going from my 8 to 72. I know that scale factor from 8 to 72 is going to be 9. And 2 times 9 is going to give me 18. And again, you don't have to solve these both ways when you're solving these on your own. You can solve them any way you would prefer. I'm just showing you that you can do these in both ways. Now, there is a little bit of a problem in this specific word problem. If you see here, we see that every 3 ounces of soda has 33 calories. How many calories do 6 cups have? Now, we run into a problem because we have 3 different units. We have ounces, we have calories, and we also have cups. Now, again, the problem is we don't have any matching units here. So the solution to that is to convert your units into something you can work with. Now, I know for a fact that 8 ounces is equal to 1 cup. And I would rather convert this into ounces because I can much easier convert 6 cups into ounces versus having 3 ounces turn into a cup. So what I'm going to do is I'm going to write ounces over calories. I'm just going to put cal for calories for both of my ratios. So I know that 3 ounces contains 33 calories, and 6 cups, now again, I know that 6 cups or 1 cup has 8 ounces. 6 cups should have 48 ounces of soda. I want to know how many calories 6 cups of soda has. So I can tell from here to here, it's probably easier for me to go from 3 to 33 because that's multiplying by 11. 48 would also be multiplied by 11. Now, I know that 48 times 11 is going to give me 528. So I know that in those 6 cups of soda, I'm going to have 528 calories. Now, in my next example, I see that every 10 minutes, Frank types 20 sentences towards his essay. If we left Frank alone for 2 hours, I want to know how many sentences he would have then. So what I'm going to do is I'm going to write a second word ratio, but again, we run into this problem of having different units. We have minutes, we have sentences, and we have hours. Now I know that I can turn hours into minutes because 1 hour is equal to 60 minutes. So my word ratio in this example, I'm going to put sentences on top and minutes in my denominator. So I know going from 20 sentences in 10 minutes, we now have to go to 2 hours, and that's 120 minutes, but I don't know how many sentences we're going to write for that. So I'm going to use whatever I feel is fit. So in this case, I can see that I can go from 10 to 20 because this is just twice the amount of sentences for each minute. 120 times 2 is going to give me 240. So if I leave Frank alone for 2 hours straight or 120 minutes, I can see that he'll type 240 sentences. In our final example, we can see that Heritage forms a gardening club. The 6-foot planters that they bought provide Heritage with 4 pounds of tomatoes, and we're curious as to how many pounds of tomatoes we would get if we were provided a 3-yard planter. So again, just like the last time, I'm going to underline my units. I see that I'm comparing pounds, feet, and yards. Now again, I can't compare 3 different units, so what I'm going to do instead is I'm going to just compare the feet to the number of pounds of tomatoes I'll get. So I should know prior that 1 yard is equal to 3 feet. So my first ratio will be written out as 4 pounds over 6 feet. And that's equivalent to, again, we have 3 yards, so that's going to actually be 9 feet. we want to know how many pounds of food we'll be getting then. So here, it's probably easiest to go from left to right, comparing my two ratios. So I'm going to solve this and find my my scale factor, I should say. So I know that 6 times something is equal to 9. I divide both of these by 6, and I'll see that my scale factor is 3 over 2. So if I multiply this by 3 over 2, I'd also have to multiply 4 by 3 over 2. Now I know that 4 times 3 over 2 is going to be 12 over 2, which is also equal to 6. Now that you've gone over a few of the examples, you are to complete the activity assigned to proportions. If you have any questions, please feel free to still message me on Schoology. I will still be in the building. Thank you.